So this is probably what you think of when you're thinking about a wind turbine. You basically have, this kind of housing up here, and then you have these big blades that are sticking out into the wind. And this is what we call a horizontal axis wind turbine, right? The axis that's being rotated is horizontal, right? Parallel to the surface of the ground. Yeah. These are great, and the way that they work is very simple, right? So if we keep thinking about, what are the different ways that we can create energy, and we just keep talking about spinning the magnet, this is the pinwheel, right? So each of these different types of energy we've been talking about have a turbine, right, that's spun somehow. Here, we're spinning it just by the wind, right? We literally built a pinwheel to do that. And so as it's rotating, we've got magnets and copper wires, and it literally will spit out energy. Great. One of the problems is that a wind turbine, to generate a lot of energy, has to be really big, right? Really big enough that we do not actually have those in the United States. So you need a lot of them. And we'll talk about some of those numbers here in a minute. The other thing to keep in mind with a traditional wind turbine is that one of its kind of hang-ups is all of the mechanical work that potentially would need to be done, or the maintenance work, is really high up in the air, a couple of 100 feet off of the ground, right? Someone's got to go up there and work on it. That's great, because they're going to get hazard pay. But because of that, we've actually seen some other types. The other kind of main type of wind turbine that we have looks something like this. So this is what we call a vertical axis wind turbine, and it has kind of sails and works almost like an anemometer, if you've ever seen one of those spinning that will determine wind speed. So this works in a similar way. It's got these blades that stick out, and when the wind comes by, it spins. The advantage is all of the maintenance and mechanical work that has to happen happens on the ground. And the other disadvantage of this kind of traditional wind turbine is it needs to sense the direction the wind is blowing, and it has a motor inside of it that mechanically will turn to orient itself in that direction. That's not true. This is like an omnidirectional wind turbine, right? And so the disadvantage is that wind speeds increase with distance off of the ground. So these are generally lower to the ground, so the winds that they're experiencing are not what you would experience 300 feet off of the ground, because there's a lot of drag right at the surface. But still, they both kind of have their applications. So if we're thinking about wind, and one of the things we'll see in the next video is that wind is big time, right? Wind is something that we're really actually using a lot. And if you were to have yours installed in 2020, so kind of modern era, the average wind turbine in the United States generates about 2.75 megawatts. And that's not a lot, right? But it's significant, right? So if you put in 100 wind turbines, you've got 275 megawatts, right? So that's significant. That's more than a lot of hydroelectric installations. So the power in wind turbines is, again, the number, right, in the density, right? You see these wind farms. And really the first commercial wind farm that we put in, I think, was in New Hampshire, like about 1980. So really, we've seen that improve significantly since then, right, over the last 40 or 50 years. Just doing kind of bar napkin calculation, one of the things we point out is the wind doesn't blow all of the time. Some places are more windy than others. But if you put a wind turbine, whether it's horizontal or vertical axis wind turbine, in an optimal location, place that gets enough wind to generate power, generally the number that people use is you're getting about 40%. Over the course of the year, you're getting about 40% of that capacity, meaning sometimes the wind's blowing a lot and you're getting full capacity, right? If it's sustained, fairly strong winds, but other times it's not blowing at all. So over the course of the year, you're probably getting a fraction of that. But again, power in numbers. And if we think about what this really means for a standard household, a 275 megawatt wind turbine needs to spin for about an hour at 40% capacity to power your house for about a month, right? So that's pretty big, right? But again, this type of wind turbine is not the type you're going to have at your house. That's, one that's a couple of 100 feet tall that you could see from all around. Home wind turbines are much smaller than that. But again, they kind of spin for more time. So the last thing that I want to talk about with wind turbines is, first of all, we've talked about putting them where the wind blows. And so we can actually, here's a map where you can see the potential for wind power. And if we notice, at least in the United States, that the plains in particular, those are places that have generally sustained winds kind of year in and year out. So those are really great places to put wind turbines. The Snake River Plain, where we live, that's a pretty good place. Out in the ocean, we talk about kind of ocean or offshore wind installations. Now, these are a really big deal in Europe, right? Germany has lots of these, and that's where you can put the really, really big ones. And so out in the oceans are flat, right? Well, they're spherical, depending on what scale you're looking at. But over the flat ocean, the wind tends to blow consistently. And so those generate a lot of consistent power. The largest wind turbines, I think the largest one that's kind of built is, I think, 14 megawatts. So this is a German company who makes the largest wind turbine. Kind of as of my most recent check, it won't be commercially available till 2024, if everything goes well. But most of the ones that are put in the United States are a fraction of that, and they're land-based, right? So again, like 2.75. And again, those are modern ones, right? So if you have a wind turbine that was put in 10 years ago, if you drive past an old wind farm, those are probably closer to 1 or 1.5 megawatts per. But again, these really, really big ones, they kind of require a grid that can handle power fluctuations. And we don't have that in the United States, right? Our downfall is our grid can't handle the variability of power generation, right? We're built for what we call baseline power, but that's not true across the world. Lots of places can handle this. And then the last thing that's always worth pointing out is the birds, right? So that when people talk about complaints of wind, I think there was some discussion a few years ago about wind turbines giving cancer. Got a lot of people kind of giggling. But they do create some noise, right? So you don't want it necessarily in your backyard. I believe the legal offset from residential is something like 300 or 500 feet. At 500 feet distance, they're probably about as loud as a lawnmower. So that would mean it would sound like your neighbor was constantly mowing the lawn. But that drops off, right? Farther away that you get. But another one that people always talk about is birds, right? So bird deaths caused by wind turbines. And in my mind, this is a little bit disingenuous, right? When most people say that. This is kind of opinion here. So birds, right? Birds are a big issue, right? People talk about wind turbines kill birds, and they do. So annually in the United States, just shy of about 700,000 birds killed each year by wind turbines, and that's a big deal, right? We don't want that to happen. We do have some interesting kind of deterrent systems. There's another kind of thing that researchers who keep track of bird migrations have been doing. And when birds are migrating in large numbers, they'll actually force wind turbines or wind farms to shut down as these kind of crowds of migrating birds are moving through. But when I say disingenuous, I'm thinking about, people throw this big fit. I don't want a big wind turbine because it's going to kill birds. So again, just shy of 700,000 killed So again, just shy of 700,000 killed directly by wind turbines each year. That's a tragedy. But if we compare that to the amount of birds killed by cats each year in the United States, that number is 2.4 billion, right? So what I see is that someone's up there saying, I don't want any wind turbines because they kill birds. And then they go home and they've got a cat, right? They've got two cats. And so you kind of think like, I don't know. I don't want to see birds get killed by wind turbines, but when you kind of put in the numbers, the numbers shake out to be about 0.3 bird deaths per gigawatt hour. So it's kind of this built-in death rate, right? Which again, that sucks. So compared to other, perils of being a bird, wind turbines are fairly small. But again, it definitely exists. Okay, so the last thing that we're going to get into is we're going to kind of start talking about what are the trends that we see, what are the balances between all of these different sources of energy, what does the future look like, and again, hopefully we can start to get out of the depressing part of this class and get into the how can we fix this, right? What should we do? How are we going to generate electricity? How are we going to continue to have transportation, and how can we do it in a reduced carbon or carbon neutral or dare I say it, a carbon negative way? All right, I'll catch you in the next video.